Welcome back, guys! This is another episode of Double Pi Engineer. Today we are going to create a fun project in order to control DC motors and also have a LED display with them. At first we are going to need a DC motor of your choice. I am using a 5V DC motor, but you can use whatever you want. The only thing that changes is the supply voltage, but always keep in mind that the ground on microcontroller must be the same with a DC motor. Our next component is a Mosfet, which is going to act like a switch for our motor. I am using WS2812b, which is an overkill for this circuit, but I have plenty of them, so I must use them. Plus, we're gonna need a 10k ohm resistor. You are also going to need a LED strip of addressable LEDs, such as WS2812b. You can use as many as you want, but keep in mind only to declare them, the number of them in the code, and supply them with external voltage, because as you know they consume a lot of energy. At last, we are going to need a microcontroller. You can use whatever type of Arduino microcontroller you want. At first, we are going to connect our DC motor and Mosfet with Arduino and check them if they work well as we want it so. The diagram of the circuit is being provided at the bottom right of the video, in order for you to know how I have connected the circuit. The full schematic of our circuit is being provided at the link of the video down at the description. So, let's see the code in our video. So, let's dive into the code. First of all, we are going to include the IR remote library, also the Adafruit NeoPixel library, and the AVR power library. At first, we are defining the pin that we're gonna use for our data for our NeoPixels, or our addressable WS pixels. Second, we just write here the number of pixels that we are going to use. In my case, I'm using 8 addressable LEDs, so this is why I told you can use how many as you want. Moving on, we are declaring the Adafruit NeoPixel library. This is the delay value between our pixels. I've set it to 0.1 seconds. And this is a receive pin for our transmitter. I've set it to pin 11. Our DC motor pin is at pin 10. Moving on, I have read the values, the hex values of my transmitter. The 0 button is this hex value, the first button is this hex value, and the second is this, and the third is this one. So you have to do it that yourself. You're gonna use the IR remote library, the basic example, and you're gonna read from your transmitter the values of your controller, of your transmitter, and set it up here. They must be unsigned long values. Moving on to the setup. Here I'm doing the everything for the 16 megahertz clock. You have to only print that. So I set the pixels begins that initialize the NeoPixel library. The serial begin which we needed for IR. And then moving on, I enable the IR in that starts the receiver. And I'm setting the pin mode to DC motor at output. Moving on to our void loop, we're setting here an if that says if the IR transmitter decode result, etc. Then we print the value in hex. And then we store the value at input. We have a bit of delay here, just to make sure that everything works fine. And from now on, we are just taking the value of a hex, the hex value if it's like ours. So if input IR is the first hex value, we're going to print check 0, which is in order to debug the program at our serial monitor. We're just using for debugging purposes. Then we run our pixels as we want it. So I'm running the pixels at red color here, not bright green. I'm writing the DC motor a signal of 70, doing the same thing for button 1, doing the same thing for button 2, and doing the same thing for button 3. At the end, I'm just taking if our input it's not button 0, button 1, button 2, or button 3. I'm writing at serial monitor stop, and I'm also writing at our DC motor 0 value, so our DC motor doesn't move when we are pressing another button. Thank you very much guys for watching. Stay tuned for more videos and make sure to click the subscribe and like button like crazy if you like the video. Bye!